Download this code from codegive.com, link in the description below. OK, let's dive deep into low-level rpython, covering its principles, how it differs from standard Python, common challenges, and practical examples. This will be a comprehensive guide to get you started with writing efficient and constrained code for use with the pypy toolchain. What is low-level rpython? rpython, restricted Python, is a subset of the Python language designed specifically for building interpreters and other systems-level tools. Its primary purpose is to allow you to write code in a relatively high-level language, Python, and then, through the pypy toolchain, translate it into a more performant, often lower-level language like C. Why use low-level rpython? Performance rpython is not about writing general-purpose Python code. It's about writing very specific code, often interpreters, compilers, emulators, or other highly optimized tools, that can then be translated into optimized native code by the pypy toolchain. The translation process performs static analysis, optimization, and code generation. Control low-level rpython gives you finer-grained control over memory allocation and data representation. This is crucial for building systems where you need to manage resources efficiently. Bridging the gap. It simplifies the process of creating fast interpreters for dynamic languages, allowing you to experiment with language design without sacrificing performance. Safety. It provides type safety and bounds checking, when enabled, to help prevent common errors in low-level code. Key characteristics of rpython. Static typing. rpython enforces a static type system. This doesn't mean you write explicit type declarations everywhere. Type inference is used extensively, but the translator must be able to determine the type of every variable and expression at compile time. This allows for more aggressive optimizations. Limited features. rpython restricts the use of many Python features that make static analysis difficult, example dynamic class creation, eval, exec, arbitrary code injection, and uncontrolled introspection. Garbage collection. rpython usually includes a garbage collector. You generally don't have to manually manage memory, although there are options to use manual memory management with arenas or other techniques in more advanced scenarios. Translation. The pypy toolchain translates rpython code into C code, which can then be compiled into a native executable. Other backends, example JVM, are also possible. Object model. rpython has its own object model that differs from standard Pythons in some respects. Deterministic behavior. rpython aims to be deterministic. Avoid using features that introduce non-determinism, example relying on hash ordering. Low-level rpython, going deeper. Low-level rpython takes the restrictions of rpython even further to provide access to more direct control over memory, data structures, and execution. It allows you to write code closer to the metal, so to speak. Key aspects of low-level rpython. Raw memory access. You can work with raw memory buffers using rpy, rpython foreign function interface. This allows you to allocate memory, read from and write to specific memory locations, and reinterpret data in memory. Structures and unions. Rpy lets you define C-like structures and unions to represent data in a memory-efficient way. Pointers. You can use pointers to navigate and manipulate memory locations directly. This requires careful management to avoid memory errors. Foreign function calls. Rpy enables you to call C functions directly from your rpython code. This is essential for interacting with operating system APIs, external libraries, and hardware. Asterisk no boxing asterisk low-level rpython can reduce boxing of values. In standard rpython, every value is typically wrapped in a pypy object. Low-level rpython can sometimes eliminate this overhead for primitive types. Common challenges and considerations. Asterisk memory management asterisk even with a garbage collector, understanding memory allocation is crucial. Low-level rpython gives you more rope to hang yourself with if you're not careful. Memory leaks, dangling pointers, and buffer overflows are possible. Asterisk type errors asterisk the static type system can be strict. You'll need to ensure that your code is type consistent. Asterisk understanding rpython's object model asterisk be aware of how rpython represents objects and values internally. Asterisk debugging rpython code can be more challenging than debugging regular Python code. You'll often need to use techniques like printing to the console, logging, and examining the generated C code. Asterisk translation errors asterisk the translator can sometimes fail to translate your code if it detects unsupported features or type errors. Understanding the error messages and how to fix them is important. Asterisk learning curve asterisk low-level rpython has a steeper learning curve than standard Python or even rpython itself. You'll need to invest time in understanding the concepts and tools involved. Tools and setup. 1. pypy asterisk install pypy. The pypy distribution includes the rpython toolchain. You can download it from the pypy website, https://www.pypy.org/download.html, https://www.pypy.org/download.html. 2. rpython executable asterisk make sure the rpython executable is in your path. This is the translator that takes your rpython code and translates it into C. It's usually located in the bin directory of your pypy installation. 3. pypy executable asterisk make sure the pypy executable is also in your path. This is the pypy interpreter. 4. text editor /IDE asterisk use a good text editor or IDE with Python support. Example 1, a simple summation function. Let's start with a basic example to illustrate the difference between standard Python and rpython. Now, the rpython version. To translate this, save it as sum_list.py and run. This will generate a C file and then compile it into an executable, usually named sum_list_c. You can then run the executable directly. Asterisk key differences asterisk. Asterisk entry underscore point asterisk rpython requires an entry underscore point function. This is the function that will be called when the translated executable is run. Asterisk static typing, implicit. Although we didn't explicitly declare types, the translator infers that numbers is a list of integers and total is an integer. If you try to pass a list of strings to sum_list, the translator will likely complain. Asterisk rpython restrictions asterisk standard Python features like dynamic class creation or complex object manipulations are generally not allowed. Example 2, using rpy for raw memory access. This example demonstrates how to use rpy to allocate memory, write data to it, and read it back. This is a more representative example of low-level rpython. Explanation asterisk. 1. Imports asterisk. Asterisk rpy provides access to C-like data types and functions. Asterisk ltype defines low-level types. Asterisk rgc allows you to interact with the garbage collector. 2. Allocate _an use memory asterisk. Asterisk rpy.size of rffi.int asterisk gets the size of a C integer in bytes. Asterisk rpy.malloc size flavor equals raw asterisk allocates a block of memory of the specified size. The flavor equals raw indicates that we want a raw memory allocation, not initially managed by the garbage collector. Important, if the raw memory contains pointers to Python objects, you will likely need to specify flavor equals gc. Asterisk rgc.add_memory_pressure, size, asterisk informs the GC that you have allocated some memory. This can help the GC make more informed decisions about when to run. Asterisk rpy.cast, rpy.craptr, rffi.int, buff, asterisk casts the raw memory pointer, buff, to a pointer to an array of C integers. This allows us to access the memory as if it were an array. Asterisk I equals I asterisk 2 asterisk asterisk writes even numbers to the allocated memory. Asterisk value equals I asterisk reads values from the allocated memory. Asterisk rpy.free, buff, asterisk frees the allocated memory. Crucially important to prevent memory leaks. Asterisk rgc.remove_memory_pressure, size, asterisk tell the GC that this memory has been freed. 3 error handling asterisk the code checks if rpy.malloc returns a null pointer, indicating memory allocation failure, and raises a memory error. 4 try, finally asterisk the finally block ensures that the memory is always freed, even if an exception occurs. To run this example asterisk 1 save the code as memory_example.py. 2 translate it using rpython memory_example.py. 3 run the executable /memory_example_c. Example 3, using structures with rpy. Explanation asterisk 1 structure definition asterisk type.struct, point struct, defines a C-like structure named point struct with 2 integer members, x and y. Point ptr equals type.ptr, point struct, defines a pointer type to the point struct. 2 memory allocation and usage asterisk rpy.alloc_struct, point struct, allocates memory for a point struct instance. Point_ptr.x equals 10, assigns values to the structure members using the pointer. Rpy.free_struct, point_ptr, frees the allocated memory. Example 4, calling a C function from rpython. This example demonstrates how to call a simple C function from rpython using rpy. First, create a simple C file, example my_library.c. Compile it into a shared library. Now, the rpython code. Explanation asterisk 1 rpy.lexternal asterisk this function is the key to calling C functions. Asterisk add asterisk the name of the C function. Asterisk rffi.int, rffi.int asterisk a list of the C function's argument types. Asterisk rpy.int asterisk the return type of the C function. Asterisk sandbox saf equals true asterisk indicates that the C function is safe to call from a sandboxed environment, pypy sandboxing. If your C function has side effects or accesses external resources, you might need to set this to false. *_ no wrapper equals true * this is important for performance. It tells rpython not to generate a Python wrapper function around the C function. This avoids the overhead of converting Python objects to C values and back. *compilation_info equals provides information needed for compilation. This includes *libraries equals DL, instructs the linker to use the dynamic linker. DL is a standard library. Add your shared library. In some environment you may use my_library. *library_ders equals, if you installed the shared library in a non-standard location, specify the directory here. Asterisk includes equals, specify include directories here. Add your header files if needed. 2. Calling the C function asterisk. Once you've defined the external function, you can call it directly from your rpython code as if it were a regular Python function, result equals add, a, b. To run this example asterisk. 1. Save the C code as my_library.c and compile it into a shared library, my_library.so or my_library.dlib. 2. Save the rpython code as call_c.py. 3. Make sure the shared library is in a location where the linker can find it, either in the same directory as the rpython script or in a standard library directory. Alternatively, you can specify the library _ders in the compilation_info. 4. Translate the rpython code, rpython call_c.py. 5. Run the executable, /call_cc. Important notes asterisk. Asterisk error handling with C calls asterisk. When calling C functions, be aware that C functions do not raise Python exceptions. If a C function returns an error code, you need to check for it in your rpython code and handle the error appropriately. Asterisk memory management with C calls asterisk. Be very careful about memory management when calling C functions. If a C function allocates memory, you are responsible for freeing it, or ensuring that it is freed by the C library. If you pass Python objects to C functions, make sure the C function does not modify them in unexpected ways. Asterisk C headers asterisk. If your C function requires a header file, you can specify the header file in the compilation_info. rpython will then include the header file during compilation. Debugging tips. Asterisk print statements asterisk. Use print, or rpython.relib.reprint.reprint, to print debugging information. Reprint is often more reliable than print during translation. Asterisk -verbose flag asterisk. Use the -verbose flag when translating your code to get more information about the translation process. rpython verbose your_code.py. Asterisk examine the generated C code asterisk. The translator generates C code. Examine this code to understand how your rpython code is being translated. This can help you identify performance bottlenecks and type errors. The C code is usually located in a directory named something like build. Asterisk use assert statements asterisk. Use assert statements to check for unexpected conditions in your code. Asterisk unit tests asterisk. Write unit tests for your rpython code. This can help you catch errors early in the development process. Conclusion. Low-level rpython is a powerful tool for building high-performance systems software, especially interpreters and compilers. However, it requires a deep understanding of memory management, C-like data structures, and the rpython toolchain. Start with simple examples and gradually work your way up to more complex projects. Be patient, and don't be afraid to experiment. This is a comprehensive introduction to the topic. As you gain experience, you can explore more advanced features of rpython, such as custom memory allocators, garbage collection strategies, and concurrency models. Good luck.